building anything, we need foundation. I group. We have constructed a group foundation. Okay, now we are going to start a building in B. First of all, we must be clear about the advantage of this. Why we use B. Now, DEA is capable to measure efficiency when we have multiple input and multiple output. That goes 4 output, 5 inputs, 10 output, 20 inputs. Any situation where we have multiple outputs, multiple inputs, or multiple resources or multiple outcomes, we can measure efficiency using the D. We can think of n numbers of examples. Where are the DEA examples? I gave you one example. If you are interested to measure the efficiency of each part, we get it. If we are interested to measure the efficiency of insurance firm, we can do it. But only condition that they are producing the form in the cycle, producing the homogeneous product. If they are not using the homogeneous product, okay, they are not producing the homogeneous product, and homogeneous input they are not using, then what will happen? It will be just a comparison of just like in apple to the we can't, and it could not be a wise decision to compare the taste of apple with the taste of orange. At least we can compare the apple with the apple, whether Fuji apple is more delicious than the Washington apple. Washington apple is more tastier than the Indian Kashmiri apple, or Indian apple, Kashmiri apple with some other golden apple. Then it makes some sense. But comparison, at least comparison should be, sample should be homogeneous in the class. Okay? Sample units should be homogeneous in the class. Okay. Second advantage of DEA, it provides scalar measure of efficiency. It provides a scalar measure of efficiency. Scalar measure of efficiency means only one figure of efficiency. Third advantage is DEA is non-parametric. DEA is non-parametric approach. We have already discussed this point that functional form is not required. And most important advantage of DEA is it provides information about targets. It not only says that this is the level of inefficiency, it also provides the information if you wipe out, if you want to wipe out, remove the inefficiency, what target inputs you have, what target output you have. And for finding out these two, for finding out the targets, it provides information which we use, and that information is the slacks. This information is very vital. For working out, computing the targets, we use information which is known as the slacks. There are two types of slacks. One slack, I hope those who have done the linear programming, they might have studied that in the simple matter slack variables. No. There are two types of slack. Slack related with the input constraint, slack related with the output constraint. Because the linear programming will think about the constraints, we play with the constraints. Okay? There are two types of constraints we will use. One is the output constraint, one is the input constraint. The slack associated with the input constraint are known as the input slacks. This is very important. Accessive. It provides information about the access inputs and output slacks. Provides information on what? Access? Fine. Right, is that input output shortfall. And input slack. Slack are expressed with the help of capital letter or small letter s. Since input are required to be reduced, therefore the super subscript is written minus s minus. This will be the notation for the input slacks. For output slack, what should be here? Plus or minus? Plus. Okay. This is a great advantage. That this is a great advantage. Advantage is data segment analysis provided targets. Targets are those things which one should achieve if one want to become efficient, if one want to wipe out the inefficient. Think about the situation. The doctor says that if you take this medicine, you will be recovered from the illness. And for that, what doctor do? Doctor do some. Doctor recommend you to take some tests. Okay? You go to the pathology lab and go in the lab. You give a blood sample, urine sample, or others. You get some information. That is known as the diagnostic information. On the basis of that diagnostic information, doctor recommend you the medicine. So that all your you get a recovery, you get rid of all the diseases. In the similar way, in the DEA, targets are provided on the basis of slacks, and this target and slacks serve as diagnostic information.
So target means your efficient running.
Target means targets to reach the efficiency threshold. If you want to reach, because the distance, we talk about this distance. We talk about this distance. Target means if you want to become efficient, if you want to improve, if there is an efficiency, it means firm has this problem. If there is an inefficiency, what does it mean? The firm has this problem, then firm is ill health. Ill health means there is a waste of production process is not optimum, I can say. Okay? If you want to move from here to here, you must have some targets. How much reduction of input I require? That will be provided by the DEA. If you want to, if you are using the output perspective, your goal is moving from here to here. Okay? And there will be output targets. If you are using input oriented model, for that you have input targets. Now that would provide for different forms we get the targets, and that help the policy maker or researcher to analyze the path by following which sample form or sample forms can become efficient. This is the diagnostic information provided. SFA does not provide anything like that. This is the scope. This is the scope of A form, B form, P form. But the advantage of this model is, along with the scope, this provides the information for targets by the policy. Okay. Let's visualize the situation. There are 20 firms in a particular sample, and you are measuring the efficiency of those. And out of 25 firms are efficient, means having score equal to 1, and 15 firms are inefficient. 5 firms are efficient, 15 are inefficient. Then all the 15 firms which are inefficient want to move to the level where those 5 firms are standing. Okay? It means all the 50 firms need to adopt the best practices which are used by all the firms. I am talking about the management perspective. Now, those 5 firms would be termed as what? If I term it as peer, I hope I am not giving a mistake. These are the benchmark firms and I consider them as a peer. Now, in all the inefficient firms, try to imitate the best practice of those 5 firms, their peers. But it is not possible for a single firm. If I am now focusing on the 15 firm perspective. And for the 15 firm, there is a firm, say judging firm. Judging is more than one. But for judging, which is inefficient, and all these 5 are efficient, so judging would be confused. We will try to imitate all the 5. At the most, he would imitate her, or maybe imitate her. Okay. Now, this information is also valid. This information is very vital in the sense that it helps us, the individual firm, to decide to whom they should follow so that they can mitigate the level of injustice. And this information is also provided by the DEA. To whom they should follow. And last, let's go. I'm talking about all these 5 and there are 50. Most of people say are following this and this. Then to whom I would say that most strong firm, out of 5, there are 15 are following. Out of 50, 10 are following this and 9 are following this. So you say, how possible that 10 to this and 9 to this? Because one firm can follow multiple. Okay? Now, and there are few out of 50, they can follow, 3 are following this, 2 are following. Now these 10 and 9, which is the peer one, would be the strong leader. Would be the strong firm, because always we try to follow the stronger picture. Therefore, we have to work out the peer and peer count. We should count peer, how many firms are following, how many, to whom, how many times. That information will provide us to decide about the industry leader. Okay? Industry leader or the most robust firm in the industry. Industry leader are the most robust and strong. This vital information is also provided by the DEA. And that's why DEA got a lot of popularity. And there are, if you try to work on the consultant firm, you will find many consulting firms which are providing services to the private sector. Okay, private, those who want to do it, they use the DEA. And they use very basic DEA model. Because their criteria is such that the people want to know about the competitors, they know how to do it, they prepare some charts from them or other things. Now, again come back to the advantage. One advantage is if you not have this, it is capable for handling the multiple input and output. It is scalar measure of that it provides the targets using the slacks, and fourth it provides the information about the peers. Okay. All these things make it advantage over the other way. But there is a problem here. The problem is that this technique has a disadvantage. And this advantage is that it is completely true. It is completely deterministic. But I already mentioned bootstrapping and stochastic DEA models now have been developed which cover up or try to overcome this limitation. So those are advanced models, maybe actually those are very easy models, but computers are very expensive and the software earlier was available, now there are problems. The who developed the software is not providing the license for the fee to the earlier all the research provided, all the consumers that they develop the software in a free year. It was in the R language. Earlier that was free to all, but now they are not providing free as they now have the key and they are not providing the key to them. I don't know why they are doing this way. But anyway, there are other software which are not free. You can do the bootstrapping. But anyway, I think if we continue the discussion on this, we will deviate from the topic. Okay. After limitations and advantages, we come to the model. The very first model of DEA is known as the CCR model. Now we come to the complete mathematics. But I will try to guide the mathematics. Okay, sir? It is completely deterministic. That is the main limitation. It is a deterministic model. But tools are available to overcome that limitation. One is the tool are available, and second is that there is certain attempts to marry the DEA with the SFA. Why it's not popular? It's actually a small, actually only one model, which is provided at reprints. Okay, they add 1%. It is basically a DA model. They remove the constraint. Actually, in linear programming, you might have listened the term convexity constraints. Okay, in FDX, convexity constraint is removed. Okay, it means the physical region need not be convex, it may be concave also. So what my point? That's why that this is only one model. That is not the problem. But if you Google it, you will only find not more than 100 articles on FDA. Only one model, 100 articles. But if you go to the DA, in email level, you will all so many more. Anyway, we come to the CCR model. Now this model is named after its developer. CCR model. CCR model is named after its developer. There are three developers. One is Carnes. Kumar and Boris. Carnes, Cooper and Boris. They wrote a model. They wrote a paper in 1978. They submitted the paper to EGO. EGO is European Journal of Operation Research. And the paper was published in that journal, and the model which they well, because there was money taken of that model. time we will discuss about those limitations, how those limitations are removed, and this is one of the basic part. Now, please note here that this is also very interesting thing. Carpus and people are post provider. This was a primary supervisor, this was post provider, and this guy was his PhD. This guy was PhD student, and the paper was a part of his PhD thesis. Now, in the 1978, I can well imagine that there was a sincerity among the people. Actually, now in these days that is not actually one example. Now, this is part of the PhD dissertation, but he will put that into the Carpus and do. But now these days is different. I tell you a story. One of my PhD students sent a paper to the journal, Indian journal, very well established and very reputed Indian journal by the Institute of Technology. He gave his name and my name as a quote. Obviously, my name was second. The paper went to one of my friends for review from IIT Bombay, in IIT Bombay. That friend of mine is a very famous economist. She professionally very clear. She put the paper on the revision. There was no problem in that paper, but overall paper looks seems good. Anyway, when the paper published, my name was not. The reason was, when we submitted the paper, he was doing DEA. And generally, it takes 2 years to get published in a good paper. Generally, it takes 2 years to get published. 6 months. First 3 months, they generally look for the referee. After the referee consent, they send the referee to the referee. That takes about 3 to 6 months. Then generally the visa. Then after visa, you give a time to 3 months. Visa will take. Meanwhile, he cleared his PhD, and later on, when he was clear that nobody is to take care of me, my work is done, he wanted better to the editor, and editor was the better feeling from the student. And he knew me very well. He rang me. I got a paper request for giving your name for it. Unethical, uncomfortable, is no way to do it. That's the answer. Now, anyway, leave that. That is what to come to the CCS model. CCS model, which is the first model, which is developed by the Carpus, Cooper and Roy in 1978. And there are 2 versions of this model. Implementing and output. Before starting the implementing model and output-oriented model, I make a small request to you. During my exposition of the model, if you feel that model is not digestible to him or her, don't worry, because you can copy yourself the model from any book But how to implement the model using the software, what the interpretation of output file, that is more important. Okay, now in these days, many people don't know about the mathematical thing. They know how to put the thing in the software what is result and how to implement. That is more important. But I will try my best. Okay, my endeavor will be to provide you a simple activation of the model so that you can digest. But maybe I may fail my attempt because every vegetable, every sabji is not tasty for everyone. Some people like rajma, some people like potato, some people like butter chicken. In the similar way, some people are very easy with the mathematical thing, some people are easy with the theoretical thing, and some people are mixed. That's why I am saying that not worry about what I am going to do. If you are not getting it, then close your eyes and or you can also make my sketch. Now, every model requires mutation. Every model requires mutation, and we will do some standard mutations. First mutation is J varies from 1 to n. J varies from 1 to n. What is n? N is the number of bees. Let's suppose in a sample of 15 curves, what would be the n? N will be the 15. Then I will use the relation I. I varies from 1 to n. And is the number of inputs. Number of inputs. Okay. And as for in the production process, there is land and capital and labor. 3 inputs. What is the value of that? Then I have R. What is S? S here is the number of outputs. Let's go and talk about the bank. In the bank, the output is advances and investment. There are 2 things. Okay? Then S would be 2. Okay. For running a DEA model, if you put the data in the Excel sheet, you can take n number of output variable, input variable, and sample size maybe. But there is a basic requirement. What should be the appropriate sample size to get the robust result? What should be the n? Now, the requirement is the sample size, minimum sample size, n greater than or equal to 3 times n plus s. This is the basic requirement. This is the basic requirement that your sample size should be 3 times. Now, it means if we are talking about this, if we are talking about this scenario, n is equal to 3, s is 2, 2 plus 3 is 5, multiply the 3, 15. If the sample size should be at least minimum 15. That's the robust result. And if this rule is known as the Karna's rule. This rule is known as the Karna's because Karna's provides. Karna's talk about this. Now, if this is not happen if this is not followed? If I have, let's suppose, there are 3 output, 2 output and 3 input, and I have taken and is equal to say 8. If I put the data in the software will provide the result. But what would happen? Most of the form would be having score equal to 1. It means that most of the form, maybe number of 8 6 are having score equal to say 1. In that case, there would be a low discriminatory power of the data. Discriminatory power, making comparison. Discriminatory power is required to make a use of it. I am saying that if this requirement is not followed, we have a lower discriminatory power of the model. That model would not be so appealing in the sense that most of the form has score equal to 1, which is not likely to happen. So discriminating power, only few units should we have 1 and other. So in a sample, not 75% unit or 80% unit may be efficient. Only few general with respect to few to be having score equal to 1 and others to having score less than 1. You got that? Okay, anyway, this is the method required. Your sample size should be at least 3 times and plus x. Now what is model? I will talk about firstly the output and the model. In linear programming, you might have studied, if you have studied the linear programming, that every linear programming problem, LPP, has 2 parts. One is the objective function and second is the constraints. And constraints are further divided into 2 parts. One is the structural constraints and second is the non-active constraints. Okay? X1, X2, X3, Xn greater than equal to 0, that is the non-active. The similar thing would be used, but here the objective function would be somewhat different. Earlier you have this is the objective function that is equal to C1 X1 plus C2 X2 plus C3 X2. Let's suppose out of these n form, there is a particular form. The name of the particular form is K form. Okay? That K form belongs to this sample. What I want to say, there are n form in the sample, and out of n form there is the name of the form K, and K belongs to this sample, and our enter is proved by the efficiency of this form. For this we will formulate a linear program and then try to solve it. If there are n form in the data environment analysis, there will be n linear programming, not one. In the one we cannot find the efficiency score of all. We will have n linear programming problems and we will solve. For example, there are 15 forms, there will be 15 linear programming problems. We require to solve them one by one. And it is a very time consuming process. We know that for a small linear programming problem, solving with the help of the simplest method, we at least require to construct 3 tables. Table 1, table 2, table 3, and generally we will make mistakes. Only somebody very efficient officer or some people take care of these manually required some time to solve. Maybe 15 minutes is the minimum time. Even I am confident I take 15 minutes to solve the problem. You are getting it? Now, therefore it is very time consuming process. Software is having developed, we automate the process. Okay? We will take the help of software, but first of all we must be clear what is the linear programming, what software is doing. Generally we are not aware about it. We have mathematical model, we put data, store the compute. But I will try that this is the mathematical model, is data. This linear programming is solved, okay, and performed. This is matter. The objective function of that linear programming would be like that. Maximize beta k maximize beta k CCR. Beta here is the technical accuracy of air of using CCR model. This is the objective function. Subject to the constraints. There will be two sets of constraints. One is the input constraints. After the input constraints, there will be input constraint. That is, for each input there is a separate constraint. In the similar way, we have output constraint. That is, for each output we have a separate constraint. But since we are using the summation notation, here are an input constraint, but there will be written like a single constraint because we are using summation. The input constraint will be summation energy xij lambda j xij j varying from 1 to n. J varies from 1 to n. And I we know that varies from 1 to n. Since I varies from 1 to n, therefore it means there are n constraints. And lesser of input are always desirable. Therefore, sign of equality here will be less than equal to. Sign of equality will be less than equal to xik. That is the input quantity used by the case. The right hand side, we have input quantity of the form under expression. Case form. Form K is form constant. Here, J varies from 1 to n. Here we have input quantity of all the forms. There. Expression lambda j. And you know that J varies from 1 to n. And y r j. So please note that this r vary from 1 to s. Therefore, this is not one constraint, these are the s constraints. And output quantities are, larger output quantities are desirable. Therefore, sign of constraint is greater than equal to. Okay? And this would be y r k. So please note that here we out y r k. Now, since we are here in this model, we are able to increase the output to the level of input. It means this y r k, for a particular point, we can increase the augment the increase or enhance the output. Therefore, this beta k is attached. This beta k is attached. Now, in the output-oriented model, we can increase the quantity of this by this proportionate, this percentage. Okay? Now, these are the input constraints. Input constraints. I am not writing constraints. This is the plural. Just more than one. So each input we have one constraint. And this provides us output constraints. And lambda j greater than equal to 0. This is the non-active constraint. hope idea is clear to you. Every linear programming have a distinct feature. One feature is objective function. Okay? Now, along with the objective functions, we have constraints. There are two sets of constraints. One is the input constraint and output constraint. These together known as the structural constraint. This tells us about the structure of technology. Okay? And there is another set of constraints which is non-active constraint, which is by finding that these weights are, this is the weights, lambda they are the weights. Okay? They are non-zero. They are non-zero. I didn't see. Now, output function starts from the maximize theta a. Technical accuracy of kx firm by using CCR model. You can read this CCR, no problem. But I have kept it in the special form. Okay? Subject to the constraint input transformation lambda a answer a. Okay? That is here comparing the output input quantity of a firm with input quantity used by all the firms including K. Please note, here J, there is from 1 to n, and K is also part of K. K is also part of n. Okay? Now, this is specific input quantity. That is input quantity used by K, and I am comparing this input quantity by the input quantity used by the all. Here, I am not only comparing the output quantity of K form by the output quantity used by all the form. Okay? But I kept one possibility alive, and that possibility is that firm can proportionately augment the output. Therefore, since it is output oriented model, firm has the ability to increase the output. Given the input in the output model, the form will become efficient, it can increase the output. That's why this theta is attached. And the logic, I think the logic is clear. Final constraint is lambda j. All the lambda are either positive or zero. So the lambda are non-active. Weights are non-negative. And these lambdas are known as the intensity variables. In linear language, these lambdas are known as the intensity variables. Now, maybe this may be very confusing because you may be very familiar with these type of notations, which are known as spatial notations. Maybe some people may not be familiar with that, this type of notation. This may be possibility. I am assuming that this possibility that everybody is not getting this. After eating at least 2 chapatis and a few rice, you may not be able to digest it. I think that possibility lies. That's why, to understand the model well, if I take some numerical figure and I try to write this, that will be better idea. Therefore, I am taking a hypothetical example where there are 3 inputs, 2 output and number of form I say 5 or 6. Okay? Then we will see how this linear programming looks like. Now, if I assume that there are 5 forms, y1 and y2 are the output, x1, x2 and x3 are the inputs, the 3 inputs and 2 outputs. Okay? That's what order quantities. Okay. Now please help me to fill this. Okay. Take any figure. Hypothetical not more than say 10. 0 to 10. Take any figure. Hypothetical not more than 10. Okay. You can. Then come on. 6, 8, 5, 7, 3. Okay. 3. That's 10, 6, 9, 5, okay, 2, 4, 8, then 3, 7, 8, 1. What's it? Let's keep going. 2, 4, 1, 2, 1, 3, 5, 3, not 3, 7, 8, 9, 6, 4, last 1, 2, 4. Now there are 5 forms. We are required to write 5 in the programming. I would write only 1. Rest will do yourself. Okay? But how to write it? Firstly, we are required to select it before. Okay. Now A, B, C, D, E, which is your best alphabet? Please let me know. C. Okay. D is it. Okay, I want to find out the technical efficiency of C form. Okay, how I will do it? I have to create a linear programming. I have to write maximize eta C CCR. This CCR is optional. Okay? This CCR is optional. You can skip it. Then subject to the constraints. Firstly, I would write the input constraints. There will be 3 input constraints. Okay? First input I will pick this is x1. I will please note that it is lambda j x I j. This means first if I take I is equal to 1, j value from 1 to 5 there, it would mean that first input by the first form, first input by the second form, first input by the third form, first input by the fourth form, first input by the 5th form. Since there is addition there, we have to add this. Okay, and each input quantity is required to multiply the lambda. Lambda is 5. Lambda 1, lambda 2, lambda 3, lambda 4, and lambda 4. Therefore, I will write firstly lambda 1, lambda 2, lambda 3, lambda 4, and lambda 5. Then input quantity. First input quantity for the first form 4. Then second form 3. Then 7. Then 8 and 1. Then less than equal to sign. There is 1. And what is the input quantity used by the C form? 7. But my things are not because I have a special. Special is add. I will add up. Now what is it? This is the input quantity by all form and this is the input quantity of a special. Okay. Now x I k. Then k is C, I means what? This is the input quantity used by the C form of first input. That is here it will be x I c. Okay. I hope first input constraint is alright. Okay, I will write the second. Similar way, I will take 4, 2, 1, 5 and 7. I will write the lambdas, multiply each quantity by lambda, then add this, then I here write the input quantity used by C form, and that is what? This is x to C. Then I will write the third constraint. This is 8 lambda 1 plus 9 lambda 2 plus 6 lambda 3 plus 4 lambda 4 plus 2 lambda 5 less than equal to 6. That is the right? Then input constraint is complete. We have to switch to what? 12, lambda 1 plus 8, lambda 2 plus 5, lambda 3 plus 7, lambda 4 plus 3, lambda 5 greater than equal to, greater than equal to, input quantity of output quantity produced by the C firm, that is 5. But theta is to be multiplied with this. Okay, I multiply with this theta. Theta C CCR. Then I have to write that 10 lambda 1 plus 6 lambda 2 plus 9 lambda 3 plus 5 lambda 4 plus 2 lambda 5 greater than equal to 9 theta C CCR. Then all the lambda not active to state. Okay, it means lambda 1, comma lambda 2, comma lambda 3, comma lambda 4, comma lambda 5 greater than equal to 0. Because our state is lambda A greater than equal to 0. Okay? Now if you got it, is it difficult? It means first model you have understood. Okay, your digestion power is very good. After taking kheer and other things stuff, you digested it. Now, if we want to write it for E form, what will we do? We will make only minor changes, and minor changes would be that we will bring this vector on what side? Right hand side. Let's suppose I do it. Here I write E, here I write E, here I write E, and I will replace these quantities by the E and 2, these quantities by 1, 7, down, I can write. Okay? In a similar way you can write for the rest of it. Idea is that here I am comparing the input-output combination of a particular unit or particular form with the input-output quantities, input and output quantities of all the forms. Okay? Now, solving this, now I come to that one. Solving this will require a method which is known as a simplex method. If you remember, I would not teach you simplex method, but I will take only 1 minute to describe it. Simplex method, first step is always, if you remember, is to convert less than equal to type constraint equal to constraint by adding slash variable, and greater than equal to type constraint by detecting the surplus variable. By detecting the surplus variable and adding the artificial variable. Okay? But if you don't add the artificial variable, what will happen? Nothing will happen. Why we add artificial variable? Anyone? The basic condition is that our solution is positive. That would not be satisfied. Artificial variables are always used. Okay? For computational purposes, they do not have any economic meaning to it. There is no economic meaning to artificial variables. And you might have observed that during the iteration process, artificial variable is one by one, and at the end of the day, when we have final solution, there is no artificial variable. Okay? Remember, if you not able to remember it, not even you didn't done the simplest method, forget that what I got. Okay? You focus only on this. Okay, for solving this linear programming problem, you can use any LP solver. There is a large number of solvers. You will Google, just Google LP solver, you get the list of solvers. Download any solver. Then put this problem in that. Click button submit, you will get a value of this. You will get the value of this. This will technical action. Okay, you can do it for 1 form, you can do it for 2 form, you can do it for 10 form. But when you have a large number of forms, say 200, okay, and you have 4 or 5 inputs, 4 or 5 output, things will be complicated, not complicated, your life will be hell. You feel monotonous, and when you feel monotonous, you will either create a quarrel with freebies, some are commercial software. Freebies, people created the software, execute the file, are uploaded on the net, you can download, there are manual available and okay. Now how to do this? Before going to that, I will go for the input vector model. Then we will take the data and solve the both model together. Okay, I hope this plan of mine suits you, or should I tell you how to solve this model also? Okay, I go to the input vector model. Now, input vector model. Yes, input-oriented model is minimized beta k. Minimize beta k. Okay. CCR. Input constraints, subject to the constraints. I hope it is able to decide subject to the constraints. Making anti-J, XIJ, vector equal to beta k, CCR, XIJ. Submission. Vector J, YRJ greater than equal to YRJ. Now please note that what is the difference here? Maximize by the minimize. Okay, the minimizing this theta into production. Okay, proximal input to production is now multiplied with the inputs for YRK as it is. Here, there is no theta attached with the X, there is no theta attached with the Y. Keep this thing. Okay, rest will same. Now, same problem. I hope you have more. Okay. Now I modify it because I have given data. I can raise it, you can't raise it. Okay. Now I put it. This is minimize. Here I take for number 3. Okay. Subject to the constraint, I write everything. Now this side and this side, both of the constraints make sense. Therefore, I keep same. Right hand side, this quantity and this quantity is same. Only theta is there. I write theta C CCR, theta C CCR, theta C CCR. But here, I move theta C because they will talk theta C. Okay. I hope you got it. Adjusting it. Now write. Input constraint, there are 3 input constraints. 1, 2, 3 input constraints, therefore 7.6.